This was your assessment from yesterday, so we're just going to go over that real quick. It asks you to, it's got this line L mapped onto line M by dilation centered at the origin with a scale factor of 2. The equation of line L is this, determine and state an equation for line M. So before you do anything, I think the best thing to do would be to get this into y equals mx plus b form. So let's go ahead and do that. So to do that, I'm actually going to add this y over so it becomes positive, right? And those will cancel out, and I'm going to add it to this side, and I'll be left with 3x equals y plus 4. Okay, and then I'm going to subtract the 4 from both sides, and I'll be left with 3x minus 4 equals y. All right, and this is my y equals mx plus b form, where my slope is 3 and my y-intercept is negative 4. So it says determine and state the equation for line M, and that's line L, which is mapped onto line M by a dilation centered at the origin. And we said when we're dilating something with a center at the origin, all we have to do is multiply that scale factor of 2 by our y-intercept. So 2 times negative 4 gives us negative 8. So line M should have an equation of 3x minus 8, right? Because we know dilations preserve dilations preserve slope, and we're just changing that y-intercept by multiplying by that scale factor. Moving on, so a little bit of extra practice for you guys here. I'll go through these problems, but obviously we are trying to figure out stuff that's dilated with a center at the origin. So you always have to put this into that y equals mx plus b form first, our slope-intercept form. So to do that, we would divide by 3 and divide by 3 again, and we'd be left with y equals negative 2/3 plus 8/3. So it says which linear equation could be used, could be its image, and pretty much to figure that out, you just got to figure out what's got that slope of negative 2/3. Which one's got the slope of negative 2/3? So to do that, all you got to do is change these guys into y-intercept, slope-intercept form as well. All right. And it ends up being, I think, answer choice 1 here. Answer choice 1. All right. The second question, if you want to take a look at that, it's actually the same as the one we just did in the assessment. And then the learning targets, we're still going to be able to dilate coordinates, but this time they're not going to be centered at the origin. They're going to be away from the origin. So I'll be able to determine properties of dilations, but specifically not centered at the origin today. Okay, so let's take a look at this first one. It says on the graph below, we've got these points. A is 3, 4, and then there's this line BC, and we've connected them with a line, or a line segment rather. So what are the coordinates of B prime, C prime after BC undergoes a dilation centered at point A with scale factor of 2? So to do this, all you have to do is figure out how you got from point A to point B, right? So you would figure the distance, right? And you would do distance formula, but really it's much simpler than that. You can do the slope from A to B, right? And it looks like we're going down 1 and over 1. And we're just going to do that twice. So from A to B, we went down 1 and over 1. That was once. And then from A to B again, we're going to go down 1 and over 1 again. And that would be 2 times there. And that would be B prime. Okay? And then we're going to do the same thing for C. So let's take a look at C. To get to C, we went down 1, 2, 3, and over 1. And that was one slope. And now we got to go down 1, 2, 3 again and over 1. And that's 2 slopes for us. So that's a count of 2 slopes. And that would be C prime there. And then we're just going to connect these lines, or these points rather, from A to B. And that's our new line, C prime, B prime. Okay, and that is the dilation with a scale factor of 2. Okay, so all you had to do was find out how far these points were from the center, right? The center of dilation, right? Centered at A. So this is our center of dilation. We're finding out how far this point is, and we're doubling that. We're finding out how far this point is, and we're doubling that. So all you have to do that is do 2 slopes, really, right? Rise over run, away from A. All right? So let's take a look at some more. So here we've got, this is a line 3x minus 1. It's transformed by dilation with a scale factor of 2 and centered at 3, 8. Well, what's the image after this? Let's take a look. So we've got 3x minus 1, so we're going to plot that. Okay. We know that our y-intercept is -1, our slope is up 1, 2, 3, and then over 1, right? Up 1, 2, 3, and then over 1. Okay. And let's get a line through that guy. Right. Like this. Excellent. Try to extend it some more. Okay. And it said our center of dilation this time is 3, 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, that's actually on the line. So if we dilate this line again, right? If we dilate this line with it centered around this point, we got to figure out, well, how far are the distances away, right? Well, let's take a point on this line. Let's see. If we got 1, 2, let's do this. 1, 2, 3, and over 1. Well, that looks like the same slope we just used to get this point. Well, if we got to do that twice, then we're going to go up 1, 2, 3, and then we would go over 1. And if this graph was extended, it would land there, and the line would be also on that point. So interestingly enough, if we're dilating something with the center on our line, it becomes that same line. So again, the reason this works, right, the reason it's the same line is because our center of dilation is on our original line here, right? This line with the green points is our original line, and the purple point, right, 3, 8, landed on our original line. So if it lands on our original line, when we dilate it, no matter what the scale factor is, it will always end up being that same line. Okay? Will always end up being that same line. So line N is represented by the equation 3x plus 4 equals 20. Determine and state the equation of P, which is the image of line L after a dilation of 1/3 centered about this point. Explain your answer, and then you guys have a think about it question to submit as your classwork. So those last two you are submitting for your classwork there. All right. If you have any questions, hit me up with an email and we'll do a Zoom. But these are your 2 questions for homework. Thanks for tuning in.